Lesson: Case Studies and Applications. Artificial intelligence has become a cornerstone in enhancing cybersecurity, particularly in the realm of cyber threat intelligence. The integration of AI into CTI involves leveraging machine learning algorithms, natural language processing, and data mining techniques to predict, understand, and mitigate cyber threats. This lesson delves into several case studies and applications, demonstrating the efficacy of AI in bolstering CTI, underscoring the theoretical foundations and practical implementations that have proven successful in real-world scenarios. A seminal case in this context is the application of AI in predicting and mitigating distributed denial-of-service attacks. One notable study by Shirazi et al. Highlights the use of machine learning algorithms to analyze network traffic patterns and identify anomalies indicative of a DDoS attack. By training models on historical data, the AI system could detect irregular traffic spikes and initiate preemptive measures to safeguard network integrity. This proactive approach not only minimized downtime, but also significantly reduced the financial and reputational damage associated with such attacks. Another compelling example is the use of AI in the detection of phishing attacks. Phishing remains one of the most pervasive and damaging forms of cyber threats, often serving as a gateway to more sophisticated intrusions. A study conducted by Bergholz et al. Demonstrated the efficacy of machine learning in distinguishing between legitimate and malicious emails. By analyzing various features such as email headers, content, and sender information, AI systems were able to achieve high accuracy rates in identifying phishing attempts. The implementation of such systems in corporate environments has led to a marked decrease in successful phishing attacks, thereby enhancing overall cybersecurity posture. AI's role in malware detection and classification further illustrates its transformative impact on CTI. Traditional signature-based approaches to malware detection are often rendered ineffective by the rapid evolution of malware variants. In contrast, AI-driven methods, particularly those employing deep learning techniques, have demonstrated remarkable success in identifying and classifying new malware strains. A study by Sachs in Berlin showcased a deep neural network trained on a vast dataset of known malware samples. The network was able to generalize from this data, enabling it to identify previously unseen malware with a high degree of accuracy. This capability not only enhances the speed and reliability of malware detection, but also enables security teams to respond more effectively to emerging threats. The application of AI in threat hunting and incident response is another area where significant advancements have been made. Threat hunting involves proactively searching for signs of compromise within an organization's network, often relying on skilled analysts to sift through vast amounts of data. AI can augment this process by automating the analysis of logs, network traffic, and endpoint data to identify potential indicators of compromise. A study by Chio and Freeman demonstrated the use of machine learning algorithms in automating threat hunting tasks, significantly reducing the time required to detect and respond to incidents. This not only enhances the efficiency of security operations, but also allows human analysts to focus on more complex and strategic tasks. One of the most significant applications of AI in CTI is in the realm of predictive analytics. Predictive analytics involves using historical data to forecast future cyber threats, enabling organizations to take preemptive action. A study by Sommer and Paxson highlighted the potential of machine learning algorithms in predicting cyber attacks based on patterns observed in historical data. By identifying trends and correlations, these algorithms can provide early warnings of potential threats, allowing organizations to bolster their defenses before an attack occurs. This proactive approach represents a paradigm shift in cybersecurity, moving from reactive measures to anticipatory strategies. The integration of AI in CTI is not without its challenges. One of the primary concerns is the adversarial nature of cyber threats, where attackers continuously evolve their tactics to evade detection. This necessitates the constant updating and retraining of AI models to ensure their effectiveness. Furthermore, the reliance on large datasets for training AI models raises concerns about data privacy and security, Ensuring that these datasets are anonymized and securely stored is crucial to maintaining the integrity of AI-driven CTI systems. Despite these challenges, the benefits of AI in enhancing cybersecurity are undeniable, as evidenced by the numerous successful applications and case studies. In conclusion, AI has emerged as a pivotal tool in the realm of cyber threat intelligence, offering innovative solutions to some of the most pressing challenges in cybersecurity. Through a combination of machine learning, deep learning, and predictive analytics, AI systems have demonstrated remarkable success in predicting, detecting, and mitigating cyber threats. The case studies and applications discussed in this lesson underscore the theoretical foundations and practical implementations that have proven effective in real-world scenarios. As AI technology continues to evolve, its role in enhancing cybersecurity will undoubtedly become even more critical, offering new avenues for protecting organizations against the ever-changing landscape of cyber threats.